Hi guys and welcome back to our machine learning series. Today we are discussing about one of the most important concepts in machine learning, which is supervised learning. If you are ever wondered how machines predict house prices or classify emails as spam, so you are in the right place. Let's get started. The first question is, what is supervised learning? Supervised learning is a type of machine learning where the algorithm learns from labeled data. What is labeled data? Labeled data is independent. Let's jump straight into an example in Python to make this clear. So, we are discussing each topic with the hands on example. So, for this, I'm opening my favorite editor, Visual Studio. Okay, so first we will need to create a data set. So, for this, first we import pandas as pd. Now create a data set. The first one is size in square feet. Now 1500, 1800, 2400, 3000. The second column is bedrooms 3, 4, 3, 5, and the last one again 4. Now the third column is price. Price is the dependent variable and the rest of the two is independent variable. So we need to set the price 3 lakh 60,000. The third one is 6 lakh and the last one is 5. Okay, now we need to display the data in our data frame. All arrays must be the same length 36. This is sample data set with house size, bedrooms and their prices. The target variable here is price, which is dependent variable on the independent variable. The independent variable is square in size in feet and the bedrooms. Okay, so linear. What is regression analysis? Regression is used when we want to predict continuous values. Let's implement linear regression to predict house prices based on size and bedroom. So again let's okay, so for linear regression, first we need import linear model from sklearn dot linear model, import linear regression, and the second one is import numpy as np. Okay, now first one is independent variable, which is size in square feet, and the second one is bedrooms. Okay, now the dependent variable is y, which is price. Now create and train the model. So for this we declare a variable linear regression. Okay, now model dot fit x and y. Now predict the price for the new house. Okay, declare a variable new house equal to np dot array. Now this is our new entry. Not an entry, we just need to predict the price. The size of the house is 2400 square feet and bedrooms 4. Now predict the price, which is model dot predict. The variable is a new house. And now show the print message. Predict price. Okay, we are getting errors. X is not valid feature names. Size in X does not have. Go to one dimensional array. Okay, so we are getting error here. Okay, now here you can see predicted price for the new house is 4,75,286. Now it will comes between 1800 and 2400. This price is lie between 36,000 and 50,000. As you can see, linear regression predict the price of a 2500 square foot house with 4 bedrooms to be approximately 47,005 4,75,286. Okay, now let's look at the logistic regression, which is used for classification For example, predicting if a house price is above or below $50,000. So let's move to ID. So for this we need to import the library from sklearn dot linear model import logistic regression. Now we need to add a new column which is above 50,000. So for this we use a data frame. The new column name is above 500k equal to df price dollar greater than as type int. Now again set the independent and dependent variable. Okay, the first one is the size of the house, square feet. The second one is bedroom. Now the independent variable is above 500k, which is our new column. Now train the logistic regression. So for this we declare a variable logistic regression. Now log model dot fit xy. Now predict a new house price which is above 500k equal to log dot model predict. Okay, now logistic regression tell us if the predicted price of the house is above 500k. So our model predict the price which is less than 500k. Okay, so our third algorithm is a classification algorithm. Under a classification algorithm, the first one is a decision tree. Decision trees are perfect for classification tasks. So let's implement a decision tree for predicting whether a house price exceeds $50,000. So for this, from sklearn.tree import decision tree classifier train decision tree model equal to decision tree classifier. Now fit the model dot fit x y. Now predict with the decision tree. Decision tree prediction equal to tree underscore model dot predict new house. Now print a message decision tree prediction above dollar 500k. Show yes if the condition is true. If decision tree predict else. So the decision tree prediction above 500k, which is no. Now the third one is a random forest. So random forest combine multiple decision trees for better accuracy. So here's how we implement it. So for this again we import the library ensemble import random forest classifier. Now train random forest model equal to random forest classifier. Now it will get the argument which is in estimator which is 100. Now fit the model xy. Now predict with random forest. Okay, so for this forest prediction equal to forest model dot predict which is new house print random forest prediction above dollar 500k. Yes, if forest prediction is 0, else no. Okay, we get an error estimator. Okay, there is a spelling mistake which is estimators. Okay, again ESTIMATORS. Okay. Okay, so for this one is also no. The third one is the support vector machine, which is also called SVM. So support vector machines classify data by finding the best boundary that separates the classes. So let's implement SVM. Okay, so for this we import from sk learn dot svm import svc. Now train svm dot model equal to svc svm underscore model dot fit x and y. Now predict with the svm svm prediction equal to svm underscore model dot predict new house print svm prediction above 500k. Yes, if svm underscore prediction else. Now run the code. So for this one is also no. So in this episode we covered the basics of supervised learning, explored explored regression and classification algorithms, and implemented real life examples using Python. So in the next episode we will explore unsupervised learning. Don't forget to like, comment and subscribe to our channel.